From the beginning of time, man has left his mark graphically. First with paint, and then with ink. 500 years of printing history have led to today's dominant technology, offset printing. In our daily lives, we are surrounded by offset printed goods, which generate over $600 billion in annual revenue. But society is changing at computer speeds. Digital media is rapidly replacing many traditionally printed products. What does all of this mean for the future of printing?
Indeed, what does this mean for the future of printing, and what does this mean for your future? Ladies and gentlemen, my name is Benny Landa, and I'm thrilled to welcome you here today, and it is so great to be back. Some of us may have met at Drupa 2000 or Drupa 95 or perhaps at IPEX in 1993 when I had the privilege of unveiling the world's first digital offset color printing press as the founder of Indigo. And those of you who were there will undoubtedly have heard me say that everything that can become digital will become digital. Well, has it? Certainly there are many products that today are universally produced digitally. Photo albums, very short-run label printing, transactional printing, all digital. And in the 19 years since we introduced digital printing, it has grown to 1 trillion pages a year today. However, despite all of its great success, digital printing still only nibbles around the edges of mainstream commercial printing, which is a 50 trillion page industry. So digital printing produces barely 2% of all of the pages produced. That's why we developed nanography, a new category of digital printing to go after the 98%, the mainstream. So what is nanography? Well, as the name suggests, it's based on nanotechnology, the science of extremely, extremely small particles. How big is a nanometer? Well, I'm going to help you understand how big or how small a nanometer is. You see this golf ball? If that were 1 nanometer in diameter, then a human hair would be 4.2 kilometers in diameter, 3 times the diameter of the entire Drupa messing. And you know, when you make things that small, you make particles that small, they develop extraordinary attributes. For example, metals drop in their melting temperature. Other materials become super hard, protective abrasion resistant materials. Yet other materials become easy to be absorbed by the blood, opening up new avenues to drug delivery systems. And what we at LANDA have discovered these past 10 years is that when you make pigments into nanopigments, they also develop extraordinary properties. One of them is that they become extremely efficient, powerful absorbers of light. And that is why they are at the heart of our NanoInk, and NanoInk is at the heart of nanoprinting technology. This technology has unbelievable characteristics, including very high speed, the broadest color gamut of any printing process, high optical density, the sharpest edges, the sharpest dots, high gloss and high gloss uniformity, can print on any paper, produces tough abrasion resistant images, is very low cost. In fact, the lowest cost of any digital printing technology, has a small footprint, as you can see, is energy efficient, has 100% environmentally friendly characteristics. And this last one is one I'm most proud of. Now I would like to show you a closer look at nanography. And ladies and gentlemen, I'm pleased to welcome you to the wonderful world of nano.
Hi there. Here we are, down in the depths of a sheet of paper, waiting to be digitally printed by inkjet. Though we are sheltered by all these paper fibers around us, they'll be of little protection. For when the dreaded drop hits, it will be like a tsunami, a tidal wave torrent that will drench the paper fibers and will mercilessly drown any nano folks like us. So we better get out of here. You see, when printing processes apply ink to paper, the wet ink penetrates the paper. Now this is true for all printing processes. In the case of inkjet, however, there's so much water in the ink that the paper becomes totally saturated. But paper and water don't mix. The paper gets swollen, deformed, and cockled. The consequence of all that is that you have to heat up all that water and paper to dry it out again. And that consumes a tremendous amount of energy.
So now that we've shared some of our insights about inkjet printing, I'm sure you're all very curious to know, how do we do it? How does nanographic printing work? Well, just watch.
Nanographic printing begins with the ejection of billions of microscopic droplets of LANDA NanoInk onto the special image conveyor blanket. Each row of ink ejectors adds its own color of NanoInk. Each droplet of NanoInk lands at a precisely designated location, blending with other droplets to create the final colored ink image. As each droplet lands on the heated blanket, it begins to spread and lose its water, becoming thinner as it does so. When all of the water has been evaporated, the ink becomes an ultra-thin, dry polymeric film. Let's look again. As the nano-ink film spreads and dries, it becomes only 500 nanometers thick, the thinnest ink image of any printing process. The completed image is now ready to be transferred. Because of its unique properties, nano-ink images have the amazing ability to bond tenaciously to any paper or plastic without penetrating the substrate. Upon transfer, the nano-ink film instantaneously bonds to the paper, forming a tough, abrasion-resistant laminated layer, leaving no residual ink on the blanket. Nano-ink images can be transferred to sheets or webs of ordinary coated or uncoated paper or plastic packaging films without any kind of pre-treatment. Since nano-ink images are already dry, there's no need for any kind of post-drying, so two-sided printing becomes simple and printed goods can be immediately processed right out of the press.
Well, now that we've shared with you how it works, I'm sure you want to know what it does. So we're now going to have a close look, at printed dots. We'll start with the ones you're most familiar with, which is offset printed dots. We will compare those to inkjet printed dots, and then to nano-ink printed dots. In all three cases, in this example, it's on uncoated paper stock. Have a look.
Offset printed dots have poorly defined edges and non-uniform density. Inkjet printed dots are even more ragged with poor optical density. And this is nanography. Note the extraordinary edge sharpness, high image density, and uniformity. Such a startling effect deserves a more in-depth explanation. You see, as the ink penetrates the paper, much of the pigment ends up below the surface, reducing optical density and uniformity. And just as ink gets absorbed into the paper fibers, it also wicks along the paper fibers, making the edges ragged. With LANDA nanographic printing, a dry ink film is applied to the paper, so there's no penetration and the edges are super sharp. Since these ultra-thin film images are literally laminated to the paper, they conform to its surface roughness, right down to the topography of individual paper fibers. This accounts for nanography's extraordinary ability to match the gloss of the paper, whether coated or uncoated. Unlike conventional inks, in which the pigment particles are many hundreds of nanometers in size, LANDA NanoInk pigments are merely a few tens of nanometers. These nanopigments are not only super efficient absorbers of light, but they also don't scatter light. These properties give LANDA nanographic printing the broadest CMYK color gamut of any printing process.
So what we've seen is that the thickness of the image very much affects the properties of the printed product. But it affects one more thing as well, the cost. The thinner the image, the less material you use to produce it, the less it costs to print. As you can see from this image on the screen, thickness characterizes various printing processes, and commensurate with that, their printing properties and the cost of printing. Now, some have asked us, why did you develop NanoInk as a water-based process and not solvent-based or perhaps UV-based? And the answer is very simple. Even if our customers could afford it, our planet can't. Therefore, NanoInk is based on water. Pure, clean water. Water is not only environmentally friendly, it's plentiful, and it is cheap. But until now, there's been no alternative. And we are very proud of the fact that NanoInk is water-based, because we believe that in the future, all printing must be water-based. We just cannot, as a planet, we cannot afford for it to be otherwise. Ladies and gentlemen, it is now my great pleasure to give you a brief introduction to the entire family of LANDA NanoGraphic printing presses. Have a great day.
The LANDA NanoGraphic press lineup comprises 3 sheet-fed presses and 3 web presses, spanning the entire range of commercial printing, packaging,